Hi, this is Mr. Cure. This video, I'm going to be looking at balancing and chemical reactions. So what I have here is a picture of one of my favorite reactions of all time. It's the reaction of hydrogen gas and oxygen gas that produces water vapor. And the reason I have it here, it's a great representation of what happens in a chemical reaction. So remember, in a chemical reaction, what's going to occur is that we're going to be breaking chemical bonds between atoms. And then what happens is these atoms are going to be rearranging themselves to produce a new substance, in this case, water. But you have to remember that we also have something called the law of conservation of mass, which means that whatever we have before, the number of atoms we have, has to equal the number of atoms afterwards, after the reaction is complete. So you have to kind of keep track of these different atoms before and after. So what I'm going to do is I'm going to write down a chemical equation to help us understand what's going on. So what we have here is I've got hydrogen, it's a gas, and it's going to be combining with oxygen gas to produce water. And in this case, the water is also a gas, it's a vapor. So what we can do is to help us keep track of everything is we can look at the number of hydrogens and oxygens before and after. So let's take a look at the hydrogens. So the hydrogens, we've got 2 hydrogens before and 2 hydrogens after. So that seems to be reasonable. When you look at the oxygens, you can see here we've got 2 oxygens. Here we only have 1. So we need to have extra oxygens at the end because we had 2 at the beginning. We must have at least 2 at the end. So let's introduce another molecule of water here. So now we've got 2 molecules, and to represent that in my chemical equation, I put a 2 in front of the H2O. This is called my coefficient. So this says that there are going to be 2 of everything. So for example, I've got 2 times 2 hydrogens, so 4 hydrogens altogether, and I'm going to have 2 oxygens. So it looks like the oxygens are okay. I got 2 and 2. The problem is I've got 4 hydrogens here and we have 2 here. So I have to adjust that so I can add an extra hydrogen molecule here. And now I'm going to put a coefficient in front. Oops, sorry. Put a coefficient in front. So this means 2 hydrogen molecules. So I got a total of 2 times 2, or 4 hydrogens, 4 hydrogens after, and we're all done. So what we call this a balanced chemical equation. This is something you did last year. The substances we have at the beginning are called the reactants, and the substances that we produce are called the products. And to balance, you have to make sure you have the same number of atoms before and after. And to do that, you can only change the coefficients. You can't change, for example, this H2. I can't make that H because it's an actual molecule, and this molecule is set, is defined. You'll see what happens in the next reaction. So what we have here is a typical reaction we have in our lab. We have our Bunsen burner. In the Bunsen burner, we have a reaction between methane and oxygen, and it produces carbon dioxide and water vapor. So let's write down what's happening here. So what I have here, I'm going to have my methane and oxygen combining, and they produce water vapor and carbon dioxide. So what we're going to do is we're going to write down a chemical equation for this. So let's write that down. So what I have again, I'm going to have my methane, it's a gas, and I'm going to have my oxygen molecule, also a gas, carbon dioxide, also a gas, and water vapor as well. And what we want to do is we want to keep track of everything before and after. Now we have an extra element. It's getting a little bit more complex. So I use a little tally chart to help me out. This might help you as well. So I'm going to list all of my elements here. So carbon, hydrogen, and oxygen, and the same thing after. And before I do anything, I'm going to count, make sure I know how many atoms I'm dealing with before and after. So the reactants and the products. So here I've got 1 carbon. I've got, looks like 4 of these hydrogens. I've got 2 oxygens. What do I have here? 1. Here you got to be careful. I've got 1, 2, and I have 3 oxygens. So sometimes the atoms can appear in more than 1 molecule. And finally, we've got 2 hydrogens here. So it looks not too bad. What you want to do is you want to try to tackle the more complex molecules first. I'm going to try to leave the oxygen for the end if I can. So just by looking at this, looks like the carbons are okay, but the hydrogens are off. So I've got 4 hydrogens here initially and only 2 afterwards. So let's adjust that. So let's put a 2 in front of here, so which means we're going to have 4 hydrogens. but we're also going to be changing the number of oxygens. So now we're going to have our oxygen be 2, 3, 4. Remember, we're counting the 2 here and the 2 here. So it looks like we're okay for the carbons, looks like we're okay for the hydrogens. We have to fix the oxygen. So I need to have 4 here, so it's easy. I put a 2 in front. This means I've got 2 times 2, or 4 oxygens altogether, like so. And now we have a nice balanced chemical equation. If you want to look at it visually, what it would look like would be you'd have a single methane molecule reacting with 2 oxygen molecules to produce a carbon dioxide molecule and 2 water molecules. So this is a visual representation of the balanced chemical equation you see down here. Let's try a little bit more complex one. So let's look at this one here. So what I have here is I'm going to have these substances here. So we have calcium carbonate. So let me write this down. Calcium carbonate. And let's assume these are dissolved in water. And it's going to react with sodium, also dissolved in water. And what happens here is, remember, these are ions. I've got a calcium ion, a sodium ion, and also have this carbonate ion. So these ions interact with each other. And what happens is the sodium can come in here and it can push out the calcium, so it interacts with the carbonate in something called a displacement reaction. It's called a single displacement reaction. We'll be looking at those later. So what we're going to have afterwards is this. We're going to have a carbonate, but instead of with the calcium, it's going to be hooked up with a sodium, and the calcium is going to be on its own. So let's take a look what happened here. So I'm going to have my calcium, my carbonate, and my sodium. And right off the bat, you see there's a bit of an issue here because this molecule is not neutral. Right now, I've got 1 positive, 2 negative, so I have to add another sodium in here to make the charges cancel. And I'll show you how this works in terms of a chemical equation. So let's look at sodium carbonate here. Remember, what we have here, I've got a -2 charge here, 1 positive charge here. If you use the crisscross rule, you're going to end up with 2 sodiums and a single carbonate. It's exactly what we have here. And then all we have to do is we have to add in the aqueous, and we've got our calcium over here, which is aqueous as well. So all we have to do now is just to make sure that everything is nicely balanced. Okay. So to do that, we use a little tally chart. So I have calcium. Now, because carbonate appears on both sides, I'm going to keep it together. I'm not going to separate it into carbon and oxygen. So we're going to have this carbonate and then the sodium. We'll do the same thing on this side. Keep track of everything afterwards. So we've got 1, just use a different color here. I'm going to have 1 calcium, 1 carbonate, 1 sodium on this side. Let's go on this side. This side, I'm going to have 2 sodiums, 1 carbonate, and 1 calcium. So you can clearly see there's an issue with the sodium. So all we have to do is we need to have an extra sodium over here. So that means we need to put a coefficient in front here of the sodium, 2, changing this to 2 sodiums. And now it looks like we're balanced. So the balanced chemical equation would be this over here, where we've got a calcium carbonate combining with 2 sodium atoms to produce sodium carbonate and calcium on its own. And that's kind of the idea behind balancing. I just want to go through a couple of rules with you before I let you go. So what you want to do is you want to try to balance the more complex molecules first. So whatever is more complex. Then you want to try to save simple elements like oxygen and hydrogen towards the end. And then at the end, just double check that everything is balanced. And if you have to reduce to lowest terms. For example, if I ended up with 4, 2, and 4, I would divide everything by 2 and end up with 2 to 1 to 2. The other thing is try to keep the polyatomics together if you can. And if you're really stuck, try doubling one of the coefficients. Sometimes you have an odd number, you have to kind of make it into an even number. So for example, I've got 3 of something, I can maybe multiply by 2 to give me 6. and that might help me out as well. So try these out. We have lots of examples for you in the workbook to try, and then check your answers online. Again, that's it for balancing. This is Mr. Kerr.